Hey everyone, Hammer Dan here with Hammer Performance. So today we're going to do a short video on boring twin cam cases. I've already bored one hole already, but we're going to run through the process of how we bore the other hole in our CNC 4-axis CNC machine. So of course we've made a fixture and everything to hold our case. We'll go ahead and rotate it. So first thing we're going to want to do here is level our hole. We're going to do the rear one. So we're going to jog the machine. We're going to level it, or we're going to rotate it to 22.5. That gets us close enough. And then we're going to jog it out of the way. We're going to go ahead and grab a tool. Now the way we're going to go ahead and level this is I'm just going to use a end mill, a small end mill, and the paper method to go ahead and level it to get it within 1/1000th of an inch or so level wise. Piece of paper is really thin. It's a quick and easy way to go ahead and level something without getting super detailed, and it's going to be very accurate for us for what we're doing. So once we do that, we're going to bring our hole over, kind of line it up here on where I need it, jog down and see where we're at. About right there. Then we're going to get it down close. We're going to get our paper method under here. I'm going to slide the paper back and forth until I feel that end mill come down and kind of grip the paper. About right there, and I can still pull it, so one more click. Now I'm tight. I'll look at my Z. I'm at 1.676. So we're going to jog it over to this side. Come back down. Paper under there again. Right there. 672. So we're 1/4 thou off. So I'm going to click 3 thou to level it again. We're going to go ahead and jog it back down to see where we're at. So I'm rotating the A since I was off 4/1000ths of an inch. So 674. Right there, 674. Okay, we're within 1/1000th of an inch. 1.674 on both sides. So we're going to go ahead and jog up out of the way here. So now our next step that we're going to want to do is we're going to want to go ahead and find the center of that hole. So we'll want an indicle around that. So I'm going to go to the tool that I'm going to use to cut it, and I've already pulled that tool out. So we're going to make a tool change here. We want to exit out of that. What do we want? Press 3. 3, there we go. Okay, so we're going to grab tool number 14, and that's our 1-inch end mill, as you see here. This is what we go ahead and bore the case with. So I've already pulled that tool out from the previous hole. So we don't have a tool in there. We're going to grab our indicle here. We're going to go ahead and stick this in so we can find center. And then we're going to jog it. Going to kind of get it close. Okay, let's see where we're at here. I'm going to jog it down there, and we're going to just work it around until we get it close enough. So we go to 0 here. Yeah, we're still pretty far off there. Close enough there. Okay, so as you can see over here, I set it to 0. I'm about 6 or 7 thou off. So we'll go ahead and work that around to get her to 0, 0. So I'm about 7 thou. So we're going to split that difference. 3.5. Come back over here to this side, set it to 0 again, come around to this side, and we're about a 1/2 thou. If you want to take a look at that real quick, about a 1/2 thou from 0. So it looks like we're good in our X. We'll check our Y over here. We're about a thou off on the Y. So we'll go right to 0 on that one. Then we'll just double check here. We're right on 0. We're right on 0 there. Right on 0 there. We'll check the back side. We're on 0. So we're within a 1/2 thou of round here. Okay, as you can kind of see there, as we spin it over to this side, we're at 0 there. Come over this side, 0 there. We'll come over to this side. 0 there. Okay, so we got our center point. We're right in the center of the hole. Now we're going to set our fixture, which is number 4, and we're going to select our number. We're fixture offset 11. Enter through that. We're going to store our location of our X and Y. So store location number 3. We're going to click on X and Y. And here's our X and Y fixture offset. We want to make sure those numbers match up on top. Looks good. So we'll manual out of here. We're going to jog again, get our tool up and out of there. Grab this tool out. Now we're going to put our 1-inch end mill in here. Okay. Now on the machine here, we're going to turn down our rapid travel to 50%. We're going to do a TA, 1, so we can send the program over. And over here, here's our information or our program itself. As you can see all the G codes here, we're basically cutting circles, and we're going to slow it down through the bolt hole. We had drilled, and I can show you over there when we get there, we had drilled a hole. So we can put a center bolt hole through there so we can tighten the top part of the case together. So this was our program, kind of gives us all the information we need here. So we're going to close this. I'm going to start all over just to make sure we don't have any glitches. We're going to go to our CNC program, over to the Fadal. We're going to click on all programs here. So here's all our case boring programs. As you can see, we have for all our XL Sportsters for 04 and later, for our different bore sizes, all of our 86 to 03 Sportsters as well. Over here we have our Evo Big Twin holes and then our Twin Cam holes. So we're going to do the rear. We're going to double click on our rear. We're going to connect and send the program. So back over here, we're ready to go. I'm going to turn my feed rate all the way down. I'm going to watch it. make sure we're doing the right thing here. Ready to hit the emergency stop in case anything doesn't look right. Shut off our coolant so you can see here. Everything looks good. Looks like we're in the center. Come over. Looks pretty good. Okay, so I think we're pretty good here. So we're going to go ahead, close it up, and we'll turn up our feed rate here. It's going to walk out, start to go around. All that looks pretty good. Should start cutting here as it's spiraling down. Turn that feed rate up. It's got the O-ring groove there, so it's working its way down to that O-ring groove. Now we start cutting. Okay, so we're going to turn our coolant on. Now once it gets down halfway through the program, it gets down to the bolt hole there, our through bolt in the center, and the machine will slow down. We've wrote the program to slow it down to go through that bolt hole so we don't rapid through it, that steel bolt really fast. You can see it slow down there through that center portion. We're coming up on that bolt hole in there where we just barely touch that bolt hole, but we want to cut that notch in there so it fits the profile of the round cylinder. See it just start to get into that bolt hole there, or that through bolt there. Now that we've got through that bolt, program speeds up full speed through the rest of the hole. So we're boring the cases. Actually, this set of cases is for Tucker Speed out of Utah. He's building a 124 motor. So it'll be a 4 5/8 stroke with a 4 1/8 inch bore. This is as big as we suggest on the twin cams. It's a very reliable, nice, powerful motor without really jeopardizing, too much reliability at all. We're also going to do the Timken bearing conversion on this case, just to help support the bottom end on the left-hand side there, motor sprocket or the motor sprocket shaft side there. We highly recommend doing that with the later model twin cams, just to really beef up that left-hand side to hold this bigger crank. 107 is as big as you can go without boring the cases. I take that back. A 110 from either S&S or Screaming Eagle, Harley. But as far as stock cylinders go, a 107 and boring out your stock cylinders is as big as you can go there. Otherwise, the next step up, and of course, we look at it as, if you're going to bore the cases, you might as well make a 124 out of it instead of a 117 or something of that nature. The cost is the same. The crank cost is the same. The big bore kit is the same, so you might as well maximize it there. Getting close to the end here. Once we get down to the bottom, the program will actually move back in just a little bit and finish cutting a notch as it spirals down, a little smaller hole size at the front of the at the middle of the cylinder, front of the cylinder there for the crank clearance, the connecting rod clearance there. Definitely much easier boring cases in a CNC machine than in a vertical mill manually. And very accurate. All right. So there we have it, the rear hole done. You can see here where we went through the bolt. We did that on both sides there. We need a pinch bolt in the middle, so we drilled all the way through this side so that we could put a 5/16 bolt all the way through it, and that way we're able to pinch together between the two cylinders. So we had to make sure we had that in there before we bore the cases so that we could cut each bolt, and we go ahead when we put the cases together, we'll line those up so it's perfect and then go ahead and tighten down. So all right, so there you have it, boring a set of twin cam cases in a 4-axis CNC machine. Hope you liked. Throw some comments down below. Subscribe to our YouTube channel. Follow us on Facebook. Peace out.